6.5, we're solving trigonometric equations. Now, let's look at solving this equation. 2 cosecant squared minus 5 cosecant is equal to -2. So we're solving for x. Now, we got to do a variety of things sometimes, like we have to do with regular equations. What I do is I look at this like, okay, cosecant of x is unknown here and here, okay? So I compare it to something like this. 2x squared minus 5x is equal to -2. Isn't that where the x is unknown is the same position as cosecant? So how would you solve something like this? This would be quadratic. So you get probably all the terms on one side, 0 on the other, and then solve. You could try by factoring or whatever, okay? So let's try the same thing here. This is quadratic. So let's move the 2 over and we get 2 cosecant squared minus 5 cosecant plus 2 is equal to 0. Now let's see about factoring this right here. Let's see, I'm going to break up this thing into 2 binomials. And 2 cosecant of x times the cosecant of x will give me the cosecant of x squared, or give me 2 cosecant of x squared. Now, what two things multiplied together here gives me 2. I'm going to say 2 and 1 like this. And let's check our middle term. What if I multiply these two? I get 4 cosecant. If I multiply this one, I get 1 cosecant. What's 4 cosecant plus 1 cosecant? 5 cosecant is what I want. But I want that 5 to be negative, so I'm going to call both of these negative. And check your last term. What if I multiply -1 times -2? I get a positive 2, which is what I have. Alright, so I correctly factor that. Now take each one of these factors and set them equal to 0. 2 cosecant of x minus 1 is 0. And cosecant of x minus 2 is equal to 0. Well, let's keep going. So we have 2 cosecant of x is equal to 1, or cosecant of x is equal to 1/2 here. And over there, we get cosecant of x is equal to 2. Now, let's look at solve it. Let's look at finding what x is here and here, okay? What is my cosecant of x going to equal to 1/2? This doesn't happen. Remember what that cosecant graph looks like? It's a reciprocal sine, right? Your sine function looked like this, didn't it? And it went from 1 to what? -1? And your cosecant did something like this, and it did something like that, and so forth, right? Where did your cosecant take on the value of 1/2? Nowhere, because the cosecant was either greater than or equal to 1, or less than or equal to -1. So this part right here yields no solution. Now the whole thing doesn't have no solution, just that one part right there, okay? How about where my cosecant of x is equal to 2? Isn't that the same thing as saying, okay, where's my sine of x equal to the reciprocal of 2, or 1/2, right? Where's my sine of x equal to 1/2? Also, my cosecant of x is equal to 2. So what value would that be? Pi over 6 in the first quadrant, right? Pi over 6 in the first quadrant. Where else is my cosecant of x equal to 2, or the sine of x equal to 1/2? Well, we said what? On the unit circle? At pi over 6, right? What about my reference angle of pi over 6 right here? So what angle is that? Pi, back off pi over 6, or we could say pi minus pi over 6. So another one is x is equal to, what's pi minus pi over 6? 5 pi over 6, right? Now what do we need to do here if we're looking at the cosecant, what's the period of the cosecant? 2 pi. So I'm going to add plus 2 pi in here, plus 2 pi in here. All right, let's see. Now I need to consider my n values, where n is an integer of like 0, 1, 2, and so forth, okay? Let's look at when n is equal to 0, what I have. What do I have here? If n is 0, I have pi over 6 as a solution. And if n is 0 here, I have 5 pi over 6 as a solution. What about when n is equal to 1? What am I going to get? I'm going to get 2 and 1. If n is 1, that's 2 pi plus pi over 6. So that's 2 and a 6 pi. Well, 2 and a 6 pi is outside of this, right? How about over here? What about when n is 1? We have 1 times 2 pi is 2 pi. 2 pi plus 5/6 of a pi is bigger than this, right? So I put too large here. All right, what about when n is -1? What happens? Well, think about if n is -1. That'll make that -2 pi, right? Pi over 6 plus -2 pi gives me a negative value. In this interval, I'm not looking at negative values of angles. Won't the same thing happen here? If I put in a -1 for n, that'll give me -2 pi plus 5/6 of a pi gives me a negative value. So over here, we're too small. All right, so what's my solution set to this equation right here? In the interval from 0 to 2 pi. It's going to be pi over 6 and 5 pi over 6. So pi over 6 and 5 pi over 6. Let's look at what we have next. All right, so what we got next is solve an interval from 0 to 2 pi, like we had directions there. And then we have a and b. All right, let's look at a. I have 2 times cosine of x minus 5 is equal to 3 times the secant of x. Let's see. I need to solve this equation. Well, I have cosines in it and I have secants in it. So sometimes what I have to do is I have to use an identity. I like thinking about the identity of 1 over cosine here. Therefore, it puts these all in terms of cosine. So I have 2 cosine of x minus 5 is equal to 3 times 1 over cosine of x instead of secant. Well, that's 2 cosine of x minus 5 is equal to 3 over cosine of x, right? Now I can get rid of the fraction here by multiplying both sides by the cosine of x. So if we do that, we get 2 times the cosine squared minus 5 times the cosine of x is equal to 3. Now what do I have again? I have a quadratic equation, right? Let's go ahead and subtract 3 from both sides. So we get 2 cosine squared minus 5 cosine minus 3 is equal to 0. Now what do we try next whenever we're solving a quadratic equation? We try factoring because we want to try to avoid a quadratic formula here if we can. Sometimes we have to use it, but right here, let's try to factor. Let's see. I'm going to open up my 2 parentheses here for my 2 binomials. 2 times cosine of x times the cosine of x will give me 2 cosine squares. All right, let me see how I can arrange terms here. Maybe I could put 3 right here and 1 there to give me 3, right? Now, if I multiply outer, I get 2 cosine of x. Inner, I get 3 cosine of x. Is there any way I can arrange that? no, not to come out with a negative 3 there. So what if I put maybe like 1 here instead and 3 there instead? Now multiply you out, or you get 6 cosine of x, or you get 1 cosine of x. Well, if I make that 6 cosine of x negative, and that 1 positive, 1 cosine of x positive, that'll add up to negative 5 cosine of x, and 1 times negative 3 gives me negative 3. So there we go, we have correct factorization. So what do we do next? We take each one of these factors here, set them equal to 0 and solve. 2 cosine of x plus 1 is equal to 0. Also, cosine of x minus 3 is equal to 0. Well, let's solve these. Let me see, I'm probably almost off the camera. Almost, yeah. So we get 2 cosine of x is equal to negative 1. Or we can say cosine of x is equal to negative 1/2. Cosine of x is equal to negative 1/2 for the first one. How about the second equation? If I solve that, I get cosine of x is equal to 3, right? Now let's solve for x here. Where's my cosine of x going to equal to 3? Well, that doesn't happen. Think about your cosine graph. It oscillates between negative 1 and positive 1. So this part gives me no solution. How about this part? I can find this value though. Where's my cosine of x equal to negative 1/2? First of all, where's my cosine negative on my unit circle? My cosine is negative in quadrants 2 and 3, right? Where's my cosine at 1/2? That's at the angle pi over 3, right? So I have 2 reference angles here, pi over 3. So what are the angles I'm looking for here? I'm looking for actually this angle right here, right? What is that angle? That's pi back off pi over 3, or pi minus pi over 3. What's 1 pi minus pi over 3? What's 1 pi minus a third pi? 2/3 of a pi, or 2 pi over 3? How about this angle right here, from here to here? Well, that's pi radians plus pi over 3 more. Or what could I call that? 4 pi over 3? Now what do we need to put here? We need to put plus 2 pi in, plus 2 pi in. We need to get in the habit of keeping to put plus 2 pi in. And then we consider different cases of n. What about when n is equal to 0? What am I going to get? If n is 0, I put in 0 here and here, so that zeroes out those. So I'm just left with 2 pi over 3 and 4 pi over 3. 2 pi over 3 and 4 pi over 3. That's in this interval. Both of those are okay. How about when n is 1? When n is equal to 1. If n is 1, this will be 2 pi, right? What's 4/3 of a pi plus 2 more pi? Bigger than 2 pi, right? So I'm outside of that interval. I'm over here on the interval, actually. How about this one? When n is 1, what do we have? 2 pi plus 2 pi over 3 gives me bigger than 2 pi, so I'm outside of that interval again, and I'm too large. Too large. What about when n is equal to negative 1? If n is negative 1, then I get negative 2 pi here. I get negative 2 pi there. In both cases here, if you add this number to a negative 2 pi, you get a negative number, which is on this side of this interval. So those are too small. So what's my solution set here? 2 pi over 3, 2 pi over 3, and 4 pi over 3. 2 pi over 3 and 4 pi over 3. let's look at part B here. Same directions. Solve an interval from 0 to 2 pi. But now we have a different equation. Erase all this stuff real quick. All right, for B, we have cosine of 2x is equal to cosine of x here. All right, so let's recap what we talked about so far. We talked about solving these directly. We talked about sometimes we have to end up factoring these equations with trig functions. Sometimes we have to use an identity somewheres. And that's going to be a case right here, again, where we have to use an identity, kind of like the last one. All right, how do I know we're going to have to use an identity? Well, right here I have the cosine of 2x. So 2x is my argument here. But on this side, only x is my argument, okay? So even if I bring this over to the other side and say this is the cosine of 2x minus the cosine of x is equal to 0, I cannot factor that because one of them, the argument's 2x, and the other one, the argument is x. They both have to be either x here or 2x there to be able to factor that, okay? So I can't factor that, but what can I do here? What is that cosine of 2x right here? What does this part look like? That looks like a double angle, right? Hence, I'm going to use which identity, which formula? Double angle formula. All right, go back and look at your double angle formulas, okay? Go back and look at those double angle formulas and tell me which one seems like it'll be most useful here, okay? Then we have something like cosine squared with a sine squared, like a minus in there for that double angle formula. Well, I don't want to use that one because I'm going to introduce another trig function here. I would like to stay consistent with what I have, cosine. But wasn't there one that said something like the cosine of 2, I'm trying to think of which variable they used, maybe theta in this book. Let's use x. Isn't that 2 times the cosine squared of x minus 1? Wasn't that one of my identities I had? In fact, if I use this identity right here, then I have a cosine of x with this cosine of x, and it's going to work nicely. So for this part, I'm going to call that what? 2 cosine squared of x minus 1. So in other words, all I did right here is replace this with that. Minus cosine of x is equal to is equal to 0. Make sure that makes sense to you. Now if I do this, what kind of equation do I have here? A quadratic. Everything's on one side, which is good. But let me just commute these two terms around. Let me go ahead and call this 2 cosine squared minus cosine of x minus 1 is equal to 0 if I commute those two terms around. Now that makes it easier to factor if I commuted those two terms around. I have 2 cosine of x, I have 1, I have 1, and let's see, which one do I need to make positive and negative? I need to make that one negative, that one positive for this to work. All right, set each factor equal to 0. 2 cosine of x plus 1 is equal to 0. And cosine of x minus 1 is equal to 0. All right, this will give me what if I solve this? Cosine of x is equal to negative 1/2. And this will give me cosine of x is equal to 1, right? All right, so I guess it's unit circle time. Where's my cosine of x equal to negative 1/2? Well, what did we just say about the cosine is negative in quadrant what? 2 and 3, right? And where's my cosine of 1/2? And an angle of pi over 3. So I'm going to have some reference angles here. Hey, this part's turning out to be a lot like the last problem, right? So what x values do I get from here? I get pi minus pi over 3, or 2 pi over 3. And I get x is equal to pi plus pi over 3. Or what does that give me? 4 pi over 3. That's for this one right here. How about, where's my cosine of x equal to 1? Think about your unit circle again. What is this point on your unit circle? 1 comma 0, right? Over here you have what? Negative 1 comma 0. Where's your cosine 1? Right here at an angle of 0, I could say, right? How about an angle of 2 pi? Could I say that my cosine is 1 at an angle of 2 pi? I sure could. I could say cosine of x is equal to 1 at an angle of 2 pi. But what about 2 pi? If it has a parenthesis on it like this, that's not included. So I've got to throw that one away, right? If I had a bracket on it, if I had a bracket here, it would be included. And I would keep it. All right, what do I need to do here? Plus 2 pi n plus 2 pi n plus 2 pi n. And then go through n is 1, n is 0, n is 2, n is negative 1, and all that stuff, okay? And if you do that, you come up with a solution set. I'm just going to skip to it. 0, 2 pi over 3, and 4 pi over 3.